Good.
Maybe a party bus.
A party bus to drive up the coast. That would be fun.
Okay.
Alrighty. It's working?
Probably up and running. I posted the link. I hope the others find us.
And volume and everything checked out?
Yeah, and I just want somebody who has this internet. Oops.
Oh, I have, what? Internet?
So I just want somebody to saying that from the other side that they can hear us.
I need a non-HP employee to do that because we tried that last time with my computer and I think because I was inside the house, it didn't really work. So, does anyone have a computer? You can try it from mine. You want me to hear? Let me bring my computer.
Oops.
I see it.
And can you hear? Okay.
It's gonna be back.
Okay, so
Meetup page.
who's here? See, I tweeted out. Yes, I tweeted out a picture of the cupcakes. I figured the room would be flooded.
They can hear us.
I think with non-HP employee to do that.
Delayed.
That last time with my
Delay.
computer.
It's delayed.
Inside.
Okay.
It didn't work. So.
A little bit unprofessional, but working.
Okay, so
If you click on
Big
this.
delay.
that's a really big delay.
Okay, so since the people on the meetup are a little bit delayed, you might want to either tweet questions, tweet them, or email me, or somehow we'll figure that part out because it's not going to be particularly interactive like it usually is for our meetups. A long delay, but okay, maybe we'll just have listen-only mode for the.
Just thinking how.
Oh, that's the camera.
Yeah.
Like, how are you doing that?
Google Plus.
Yeah, so Michael probably stand here most of the time when he's presenting. I doubt very much, but I don't know.
No.
Okay. So.
Oh.
Uh,
Okay, so we'll start in about 5 minutes.
yeah, we can start about 5 minutes, and the slides already shared according to the speaker. So I focus on the camera mostly for the speaker and just a little bit for the slides because the slides are already available online. And I don't have the proper camera to, shoot the slides and the speaker as well.
No, so I understand, that's great. How are the slides available online? But where? Oh, in the meetup thing?
I haven't posted them yet. I can
But where did you post them?
on my site.
And is there a reference to the site? How do they find them is what I want to know.
Oh, I can.
The slides are out there somewhere on the internet. Have fun finding them.
Well, no, I had it on my last slide. I didn't think about sharing it with. Yeah, I was gonna be like at the end of my last slide. Oh, they're already posted at this URL.
Oh, I see. Okay, so
But yeah, I could certainly
it's
post
for the
it.
people in the Google Hangout.
Yeah, sure.
And if you want, you can just, is that my computer?
Yes.
Yeah, you can type it into, is it? Travis, actually, you could grab it from there too.
Okay. About moving the back. Here. Get the
I
better.
think it's gonna take a while before it streams back here. Let's see. Okay, we're back. It's a very good connection though. Okay. Looks good.
You go. You good? Okay. Roll. Are we ready?
Yeah. We are.
Yeah, I think we'll go ahead and get started. Okay. All right. So hang out, have pizza. I love it. The presenters never actually get to eat. So I have enough stuff to actually that's important to talk to people about. So help yourself to the food, to the beverages. And by the way, to my secret admirer who brought me a gluten-free beer. Thank you, thank you. I'm going to enjoy it. It's a little sweet. I tried it. It tastes a little bit like root beer, but very thoughtful. And now I'm going to put it here because Travis is recording, and if I look like I'm drinking during the recording, we can't use it on YouTube. Fun little policies. Those of you who come to this regularly get to hear about all these fun little policies. Things like you can't move the tables, which is why they're set up like this, and you have to look sideways at things. So, you can move your chairs, but unfortunately we're not allowed to move the tables around. It's liability. But anyway, we have a lot of fun stuff for you today that we're going to talk about. We're all pretty excited because we're all heading off to the 11th OpenStack Summit tomorrow. Well, some of us are leaving tomorrow, some of us are leaving Saturday, and it's going to be a really busy week, really good week. Follow us on Twitter. We'll be live tweeting a lot of it and just generally tweeting a lot of it. So So you have Mike's Twitter address there at thingy. I'm at HP Cloud Angel. Rick Evans is Ravens HP, and Michael Aday is at Mayday. Love that one. And we can repeat that throughout. But anyway, that's the way to follow us if you're not actually coming. Couple of other really exciting things this time. See, we're also in a really good mood because of the game last night. I'm just going to keep smiling about that. So we're going to do something a little bit different. We're going to pass out some prizes. I know we don't normally do this, but we have a kind of a review survey, should we say? Because we've been doing these meetups for a while now, like every other week, and we want to get some really great feedback. Thank you, Rick, from you guys, and we want to know what we can do better. And anyway, for your effort, we are going to be, once you turn back in your survey, Amanda will give you a raffle ticket. Amanda's the lovely Amanda over there. Raise your hand, Amanda. Amanda will give you a raffle ticket, and we will raffle off at the end of the night this slate. I know, pretty cool, huh? Oh my gosh, you guys are like not even excited about a slate. It's a slate. So one of you will be going home with it if you stay till the end, and you fill out one of those forms. But there's other things that the rest of you will be going home with because we have some awesome content for you tonight. Mike's gonna be talking about Cinder. Mike's gonna be talking about Graffiti, and Graffiti is a really fun collaboration or effort that HP put together. Intel helped a lot, so we have a little HP Intel. Where are you trying?
Yeah. Just you were on.
Oh, for the camera?
Yeah.
I don't need to be on the.
Okay.
Hi everybody around the world. It's Lisa. They see me all the time. They need those guys, but you probably want to change that because I don't think Mike's gonna
I'll
stand
just
here.
point it here so that you know.
Okay.
Yeah, that's not gonna make us nervous. So what was I saying? Oh, stuff we're gonna give you. We're gonna give you a lot of fun stuff. So we have cool prizes, and then also, so because this is the beginner track, I don't know if you guys know Jacek. He's done a lot of writing for Rackspace. He and I collaborated on a book. It's an intro to OpenStack, kind of an intro to cloud book. So I just brought a few down. We did this for the Icehouse release. The last release, we rolled this out at the OpenStack Summit in Atlanta, which is also where this shirt is from. So I'm not gonna force it on you, but if you want a kind of beginning to intro to cloud, intro to OpenStack, and then also there's a little bit about HP Helion OpenStack here. Why HP decided that we were going to go all in with OpenStack, make sure OpenStack survives, make sure that we are very, very active in so many of the projects. We're currently the PTL of 9 of the projects and 5 members on the TC. And, 2 members on the board, and really, as you guys have heard me say, in other weeks, really we care about OpenStack, and it's very important to HP. So we talked a little bit about why that is, and a little bit about HP and OpenStack. So that's what that is, and if you want one, it's there. Grab one on your way out.
If we ask nicely, can we have one of the co-authors sign the book?
If you ask nicely. Yeah, we'll see if I can get Jacek over here to sign it. He's not busy. I will sign your book for you, Rick, if you'd like. I'd be happy to. But anyway, that's here for you. So lots of fun activities here today. Stuff we don't normally do because we're in really good moods because did we mention about the game last night? Yeah. So for those of you that this is your first time, we don't usually have cupcakes. We've never had balloons before, except for OpenStack's 4th birthday party. We had a lot of balloons then, but that was up in San Francisco. And Al, I did look for Old Foghorn beer. I could not find it. I don't even know what that is. Has anyone else heard of that, Old Foghorn beer? We've had some strange requests, and we try to accommodate them all. But I did try, and I couldn't find that one. So you're gonna have to send me a link or something so I can figure out what the heck. I have to try harder because I don't have enough to do. Yeah. Oh, okay. I'll just drive up to San Francisco before the next meetup. Or you know what? You're always welcome to bring your own beer if you're that specific. But anyway.
Contribution is an important aspect of open source.
It is. This is open source. You're all required to contribute. So speaking of contributing. Our format's a little bit different tonight. You guys probably noticed a camera there. We're so lucky to have the presenters here that we have tonight. And so we're asking, so we had so many requests. We weren't sure if the Google Hangout was gonna work because we've been a little bit hit and miss with that. As you can see the problems. I do think we'll get the internet back. I do think it will work. But anyway, we had some requests. So we are recording tonight. Don't worry, none of you guys are on camera. So otherwise I'd be passing around forms for everybody to sign just in case you end up on YouTube. But you're not on camera unless you happen to, rush the stage, in which case you would be on camera. So I wouldn't recommend that. So don't be nervous about that, but it's just back there. And hopefully this content will end up on somewhere on YouTube. So because of that, the format is going to be, we'll have Mike present his piece, and then we'll do some questions. If you have specific questions about Cinder, we'll take them at that time. And then we'll have Michael O'Day do his piece, and we'll talk and take questions about graffiti. And obviously, these sessions are generally collaborative, or you know what I'm saying, collaborative, whatever. So we want you to ask at any point if you have other questions throughout. You don't have to stick to that format, but that makes it easier. So, as I was saying, I'm Lisa Marie Amphy. I'm at HBPodAngel if you want to follow me on Twitter. And I'm really, really happy today to be able to introduce Mike Perez. Mike is a member of the community, as you know, and you've probably met him before at this meetup many times. And I'm so grateful that he was able to come today and actually present to you on Cinder. Because as you know, I don't think there's anybody better qualified to talk about Cinder. So without further ado, he's one of my favorite OpenStackers. He's one of your favorite stackers. Please give Mike Perez a big, warm welcome. Thank you. Oh, you can use that mic. Yeah, why don't I get you set up on that mic? That one, because then you can walk around. And then you don't have to hold the mic. But when you guys ask questions, I am going to rush at you with this microphone to make sure that the folks on the Google Hangout can hear your question and the nice folks on YouTube. But don't worry, we won't change the camera angle. But I do want your very valued questions here. And thanks again for the beer. Love ya, whoever you are.
Hello, everyone. So we're going to be talking about Cinder. And so in Cinder, we're talking about how OpenStack works with block storage in specific. So my name is Mike Perez. I am currently the project technical lead for the Cinder project. I've been involved with OpenStack since 2010. That's back at the beta release. Back then, we were looking at specifically Cinder was inside of Nova Volume. And eventually, as some of you may know, the amount of overhead in dealing with a large project like Nova, when you're mainly focusing on storage, that's a bit of, when you have to deal with the rest of the pieces of the hypervisors and bare metal at the time and networking before Neutron, even though Nova Network still exists inside of Nova today, it can be a bit of an overhead. So splitting off into our own project kind of made sense. I believe that happened back at the Folsom Summit. And we kicked around different kinds of names. You see me keep mentioning the New Kids on the Block. That was a joke. It was one of the names that was considered, and then by Vishashaya, the creator of Nova, and was one of the names. And then we also kicked around Jenga as well as Legos and so on. And as you can see, those names to name and surface up. So we stuck with Cinder block storage. Along with working on OpenStack, Daterra storage allows me to work upstream 100%. So thank you. All right, excellent. So, whoa. Don't know what's going on right there.
It's only that.
It's only on one of them.
It's a feature.
Thank you. I don't know if that fixed it. No?
No.
I hope nobody has this either.
I was going to say, if anyone has migraines, we can shut that one off. Does anyone have risk of migraines? Is that going to drive you nuts? Just a shut.
Yeah.
I don't know if I can just. Nope.
Yeah. I would say,
Oh,
That's okay.
sorry.
okay. We don't want anyone to get migraines, and there was some requests for books to be on the other side, so people don't have to run across. So while I'm here,
Okay. So yes, part of the full sum release. Again, when we're talking about block storage, we're not talking about any sort of object storage, or we're talking about file level storage. We're just talking about block storage. And in that, we're talking about volumes attaching to virtual machines. When we're specifically, when we think of virtual machines, we think of ephemeral storage. So this is your idea of having sort of persistent storage within that. So the volumes themselves have a complete independent life cycle from the virtual machine. So you can get rid of the virtual machines and attach the volume to another virtual machine. So my life currently ends up looking like this. I don't know if that's big enough for people, but there's, we just last year dealt with 8,000 patches. Not everything was accepted in, unfortunately, because we have about 353 reviewers and 9 core reviewers. So unfortunately, everything doesn't fit with our mission statement. And basically, I want to be able to provide people a way, well, I want to implement a service, a library to provide an on-demand and self-service access to block storage resources. And provide a software-defined sort of abstract layer from the software and the hardware. And I only say that because that's about the only thing I could get people to agree on with software-defined storage when I talk to the OpenStack community. So we leave it at that. So this turns into this massive grid. And this grid, each column is representing a new feature. Well, not new feature, but just volume create, snapshots, deleting snapshots, being able to create volumes from snapshots, being able to create volumes from images, and so on. And then to the left are the different vendors, as well as which release they were supporting that particular feature. And along with that, the different fabric at the time that they were supporting for those different features. So this is a huge headache, and it actually continues on as well. And really, I mean, I honestly wouldn't be standing here today if this was actually still the case. I would probably have been sacked at some summit with a SOC that was filled with quarters at one point, if operators really had to deal with something like this. And so really what I like to think that happened here is, you know, vendors want to OpenStack all the things. People are really excited about that. I also like to thank the 80s for all of the different fabrics that we have introduced as standards. And along with that, well, in general, open source happened. And that's still a beautiful thing to me. We're satisfying everyone's use cases, but we have to be able to come together and agree on some sort of interface if we're going to be providing some sort of abstract layer to the different storage hardware. So why I'm still alive today. We ended up coming together at one of the summits and with all the vendors, and we nicely came together, as we always do, and talked about our feelings and what features we wanted to support, and very mindful of all that. I would be lying to you, though, that that was not an easy meeting, but we came together with these features of the different volumes, volume features we wanted, basically the different features that we thought would describe block storage from the control plane standpoint. So along with that, you could create volumes, you could delete volumes, you can see all the volumes in your cloud as a user in a multi-tenant environment. You can attach, detach those volumes, and along with that, be able to create snapshots off of those volumes, and a variety of other features such as cloning, extending existing volumes, and so on. So those are the main features that Cinder provides today that are the minimum features that every single vendor has to satisfy. If those features aren't satisfied, they don't get accepted in. J-Pipes once mentioned before that the interfaces themselves should not actually be implementations. I am a strong believer in that as well. The interfaces should be dictating the implementations that are being allowed into the project. So before we get started, I wanted to go over some basics of just exactly, before going over what exactly Cinder is, it's kind of important to distinguish between the different types of storage. So file level storage, typically talking about network attached storage, usually given over some sort of protocol such as CIFS or any implementations off of that like Samba. And along with that, we're exposing shares, unlike other types of block storage where we have a LUN that's being exported through some sort of network portal if we're talking about iSCSI. And so along with that though, you have a variety of layers that you're going through in file level storage. And it's a great thing because it'll provide you things like coherency so that you can have the idea of multiple writers to a virtual machine and to multiple virtual machines rather. And while that's a great thing and everything, for real performance storage, I would like to take out those different layers to take away that latency issue. So in object level storage, there's a difference in terminology. Files become objects, directories become containers. We're now dealing with over HTTP protocol, and we're using verbs, HTTP verbs to be exact, like get to get the data, and put to actually upload different types of data, and we're just chunking data over HTTP. So in the common implementations that come up is things like Amazon S3 or Swift. So on the block level storage, deals with completely none of those things, has a variety of protocols that are standards. We can think of like ICER, Fiber Channel, and iSCSI, and so on. There is no coherency, so you can only have one writer at a time. You can have that block storage of whatever kind being attached to one virtual machine at a time. The reason why for this is, so we're basically, when we're dealing with block storage, we're thinking of some sort of storage area network of some sort, and basically a pool storage. And I would like to take from that pool storage, slice it into a logical volume, to which then I can associate to a LUN, logical unit number, and then export that over a network portal, so then it can be attached to a virtual machine, and it will be then exposed as a block device and mounted just the same, like you would with any block device. So again, though, you get a lot better performance, but there is also, at the same time, no coherency whatsoever. So just a little trade-off. This is a little diagram that kind of just talks about what I just said. Of having a SAN, you have a LUN. We have, in this case, a web server. In this case, it's just attaching it, and it appears as dev SDV. And so from there, you can do a mount and attach it. So at a high level, with Cinder, the one thing that I really like to get across to people at the beginning is that Cinder is in no way part of the data path. It is just part of the control path. So when you are reading or writing any sort of data off of the backend, it is just the virtual machine and the backend. Cinder is completely out of the way. Cinder is only part of the control path in the cases where user would like to go ahead and create a volume on a backend, or delete it, and so on. And then as soon as the attachment happens, usually Nova will go ahead and talk to Cinder and say, I want to go ahead and attach this volume. Cinder will pass back connection information to Nova, to which then gets passed down to the hypervisor, so then it can make the attachment. And then Cinder is completely out of the picture after that. It's only when there's a detach that happens that Cinder will step in, do the detach, and usually that's just updating the state in the database and then stepping out of the way. So one of the great things about learning about anything in any project in OpenStack is once you learn one of them, they're pretty much all architected the same. So in this case, if we're looking at, for Cinder, you have a client, you have a REST interface, you have a volume, or you have a scheduler, which then requests to go to a volume manager, or they could go to a backup manager. So specifically, we'll talk about the client first. So the client, just like a lot of OpenStack projects, are written in Python. And you can use the client in two ways. You can use it in your own Python code and import it in, or you can use the command line interface. So example, the command line interface looks something like this. I want to create a volume called my volume. So I pass the option -- name, my volume. And in this case, let me make that a little bit bigger. Not helping. That helps. So in this particular case, I have a name, my volume, and it's at 100 gigs. And I get back some response information. I get that there are no attachments to this volume because I just created it, and also that the state is currently creating, as expected. And a variety of other information such as that it's in a creating state and so on. So using the client specifically in Python code, in this particular example, we're going to do exactly the same thing that we did in the command line interface. We're going to import in the Cinder client. And from there, I could go ahead and I could pass in a variety of information such as the username, the password, the project that the user is associated with, and also the authentication URL. And usually the authentication URL is given by your cloud provider. And so in this case, I'm going to go ahead and use that client object to go ahead and say, I want to create a 100 gig volume, and I want to call it my volume. So pretty much it's the same that we did through the command line interface. So as you can see from the diagram, that the command line, or the Cinder client goes through the REST interface. And the client, the user, his or herself, can go through the client directly or could go through the REST interface directly. So the REST interface provides us a variety of CRUD operations that we could do both on volume, snapshots, and backups. And along with that, the admin can manage the quotas, can migrate volumes to different storage backends that Cinder knows about, as well as extending those volumes and transferring the volumes. The users themselves can also transfer volumes to other users. So if we take back our previous example where we go ahead and we create a 100 gig volume inside of Cinder, this looks something like this, where the request that is going to the REST interface is going to be sent to that particular endpoint. So typically 8776 port number for Cinder, and we're going to go to v2 volumes as the endpoint. And in this case, we're going to send some JSON data in the request of just the name and the size. That's it. And the response back is pretty much what we saw in the previous example when we go ahead and do it through the Cinder client. So the next thing we'll talk about is the scheduler. So the scheduler is going to take those requests and it's going to route it to the appropriate backend. So if you have one backend of one particular vendor, it's just going to send all the requests to that backend. What the user does not know, though, is that the requests do have some sort of requirement associated with them. And usually that is not seen to the user themselves, but are usually specified by the actual admin themselves. So you specify a default backend that you want all requests to go to. So by default, when I do a Cinder create 100, I'm going to go ahead and create a 100 gig volume that's going to go to some backend that is the default set by the admin. But if there are two backends associated, I can then know that it's going to still go to the default backend. But there's an idea with different volumes called volume types. And these again are specified by the backend, by the admin themselves, and the different volume types can be associated with different tiers. So you can have the idea that you want to provide slow storage, cheaper, and faster storage that's more expensive. So by default, maybe you give them slower storage, and then if they request it, they can have faster storage. Again, these can be passed in through the Cinder client as an additional option, or you could do things like through Horizon, where there's an additional option shown for different tiers. And you can call these tiers whatever you want and associate them with whichever backend you want. So next, we'll talk about the volume manager. So the volume manager is the actual logic that knows how to work with different vendors. So we have currently right now 30 drivers that we support right now. And so in this current case right now, like, we could be dealing with one backend, we could be dealing with 2 backends, 3 backends, and so on. And you would have one volume manager process associated with the backend. You can have these also set up in an active passive case, but not currently as an active active case. So in this current setup, for any sort of request that comes in from the user, will come to the scheduler, okay, and then after it receives from the scheduler picks a volume manager that can handle that request based on the requirements that came in. And after that request is routed from the scheduler, goes to the volume manager, and the volume manager will act on that request. If it's go ahead and create a 100 gig volume, it will talk to the backend using its knowledge of how to talk to that backend and talk to the backend however it's done, whether it's its own client or its own REST interface.
Question?
Yes.
In a storage pool, do you have to have identical types of storage, or can a storage pool have disparate types of storage?
So the question is, can you have different types of storage in the different storage pools, right?
In a single storage pool.
In a single storage pool. So that all depends on the typical vendor. So usually for vendors, I'm assuming you're thinking about like iSCSI and Fiber Channel and those two. Yeah. So that is usually a different volume manager process that would be associated to it. Yeah. Okay, so now we'll talk about the backup manager. The backup manager basically just knows how to take a volume that exists in some other storage backend and burn it into an object store. So in this case, the different object stores I'm talking about can be let's see, there's Swift, there's Ceph, and no, I'm forgetting another one. IBM has one out there. But so there's a variety of object stores that it could actually chunk the data out to. So, and when we're talking about backups though, there's slightly different from snapshots. So when you take an actual snapshot, you're actually, let's say it's a 100 gig volume, you're going to snapshot usually the whole 100 gig volume. Okay, and maybe your specific storage service is like, specializes where they don't use the whole 100 gigs, even if your volume isn't using a whole 100 gigs. But with the backup, it's only going to back up what is on the actual volume itself. So if you're only using 2 gigs of the 100 gigs, it only backs up the 2 gigs. That's the difference currently. So in this case though, you can have, vendor A that is not associated with, a different object store, and it will still be able to back it up. It doesn't matter. Cinder will figure it out for you. It'll chunk the data out and put it into the object store, to which then you can use those backups and you can restore them to a volume so that you can restore at a point in time. So currently right now, these are some of the drivers that are available right now. It's kind of being cut off a little bit, but those are all of them so far. And so coming in Kilo, my main things that I always wanted to take care of if I ever became PTL was to be able to handle states inside of Cinder so that we can be able to allow a case where you can run the volume managers in an active-active case. A lot of the times I find that the volume managers, with all the requests that come into them, it's just, in Python, we typically deal with this with green threads. And so that could get bogged down, in my opinion, especially with different types of backends. So I would like to have the ability to where you can have multiple volume managers that are able to talk to the same storage pool. And so in that case, I could have 100 volume creates coming in for one particular storage pool, and they could be spread out to those different volume managers, as opposed to it all going to one Python process. And while you still have HA case where you can have it running in active passive, this will still satisfy the HA case, of course, because you will have multiple of them running. But the point is that we shouldn't lose state when there are multiple processes talking to the same object. So that's what, kind of the goal with having a state machine would allow us to have. And the rolling upgrades, I don't, there's a variety of projects that are already moving towards this, where I would like the ability so that people don't have to know which order of the scheduler or the volume manager or the API server, whatever ones you want to upgrade in whatever order, shouldn't really matter to me. So those are like the two main cases that I'll be driving for the Kilo release. And along with that, the rest of the team is helping with incremental backups, as well as private volume types. So currently right now, volume types are available, are just this global thing to all users on that cloud. Along with that, we like to have telemetry support for backups. So there's no way to pull that stats currently. Backup for encrypted volumes, and a list of new drivers that you see there right now. So, and this isn't the full list for Kilo. We will definitely be adding more to this, but this is the immediate stuff that I and the rest of the team have approved in. So, along with that, that's the intro to Cinder, and I will now take questions.
Wait, hang on, let me give you the, my present notes on the Google Hangout.
How does the Cinder take care of capacity planning as well as resource allocation?
So capacity planning and resource allocation?
Yeah, just the storage capacity and storage resource allocation.
So Cinder currently right now does not handle any sort of resource allocation. That's completely up to the vendor itself to actually provide that to you. In a case where, actually, so Cinder knows about capacity that exists in a storage pool, but it does not have any sort of knowledge of how to build that up.
So actually, it's it's not that sophisticated, you understand?
What's that?
It's not that sophisticated
What is it?
in terms of, resource allocation capacity. Does not do anything on that.
Nope. It's doing message passing to the storage backend. So in a sense, like right now, I mean, instead of me dealing with over 30 different interfaces for how exactly do I actually create a volume in whatever backend. I mean, to the cloud user does not want to deal with that. And they want a single interface to be able to go ahead and create that. And a lot of them don't even care what exact vendor you're using. So in a sense, a lot of people just want the storage to be available, readily available in the cloud when they need it.
It really depends on use case. If we are talking about, if we are talking about like big data using Hadoop, or if we are talking about traditional storage vendor like EMC, NetApp, whatever, probably they are quite happy because they want to buy expensive storage devices, right? But I mean, appliance. But in terms of like Hadoop as a popular commodity storage platform, people are talking about want to do resource allocation, capacity planning, a lot of things. Because those are commodity machines, and they can be expanded infinite. So that's different kind of story.
Are you still talking about block storage though?
Now, there are two kinds of camps. One is traditional storage camps. And the other is, anyone can do storage using Hadoop, whatever, things like that. It's commodity machine. And Hadoop cluster can be expanded infinitely.
Yeah, well, I mean, people today are hooking up stuff, to Cinder. Yeah.
Next one, question here.
Yeah, I had two questions.
Yep.
One was the backup manager, how does it know what was written? Is it like a journal or something? Or?
Does it know? No. So the backup manager is not as smart as it sounds. Okay, so it's not incremental, it's not differential or anything like that. It is just a point in time that you took the backup. So it's just essentially a timestamp of when it was actually started and when it was actually completed. In a sense, I will admittedly say that it is very much like the poor man's backup solution right now. So in a sense, all it's doing is as a timestamp of when it's going to be chunking that data out and when that amount, when did that actually complete? So, and you could do a restore off of that, and you could do a listing of the backups and see the timestamps. But other than that, it's not anything fancy right now.
Okay, so then when you restore it, to kind of reassemble.
When you're restoring it, you basically do, you could do from the API or the client, you could do a list of the backups, and then you can see the timestamps, and then you can pick a backup to restore based off of the timestamp.
And then the other thing I was going to ask you is I heard something about Cinder bricks. What are those?
Oh, brick?
There's something called Cinder brick.
Yeah, okay. So yeah, brick has existed in Cinder for some time, but it's just a library that provides both target and initiator and LVM code between it takes a lot of that code and breaks it off into there. That's the real goal of it. Now, what does that actually achieve? So you talk about Nova Compute, for example, and how it's dealing with the ephemeral storage, and it's basically dealing with LVM on the ephemeral storage. It's a lot of duplicated code between Cinder and Nova. So we would like to go ahead and break that up into one library that both projects can use. So there's an idea, though, that is going to be at the summit, one of the summit sessions for Cinder called Cinder Agent that uses Brick and will allow the Cinder Agent to actually be able to manage the storage for Nova. So, and I think that would be a really awesome piece to have Cinder be able to do that, because then you would be able to I haven't really thought about it too much yet, but having the idea to be able to schedule storage onto individual compute nodes, that might be ideal. So.
One more question over here, and then I think we'll have slide will be around at the end to take one question.
So the Cinder messaging is done through backend here?
Yeah.
Okay. So let's say for a Cinder node, you install multiple vendors. Is each volume managed process different for each vendor or same process?
It's each
the
one.
volume management process.
There is one process to a backend storage, which could be to a vendor in their specific fabric.
So if I have two vendors, it's two processes?
Yes. Yeah, and then you can also, along with that, you could run those in an active passive case. I would love for Kilo to be able to run those in an active case so that you can have 3 of them going to the same storage pool if you wanted to, and they would not lose state. I have done a lot of testing on that, and unfortunately today it's not there in terms of, at some point, volume will lose state where it thought it was in a attached state, but it's actually deleted, and it's a huge mess when you have a bunch of them working at the same time.
We'll take one more question, and Rick, in the meantime, is passing out those review forms, we'll call them, and it's also your ticket to the slate drawing that we're going to do at the end of Mike's other Mike's presentation. And you have a question.
I have a somewhat basic question. We're deploying with one. We started to simply try OpenStack using audio. There's a lot of moving pieces, and I'm trying to figure out. Could you? I don't know if you can. Could you kind of go through in a single only one instance when you have local storage and then maybe backup storage in the same machine, to where you can back up all the VMs and whatnot. Can you kind of go through and figure out, explain quickly what are all the instances of these things running? Is there a Cinder backup thing on running? Is there, what are, in a single instance situation, can you kind of cut through and kind of describe more or less what's going on?
I'm not sure I completely understood.
So let's just say, so in one case that we just tried to get to deploy is, we have, the machine has 3 drives, 2 hard drives and 1 SSD. We want to deploy the VMs in the SSD drive. How would we set things up to do that?
With Cinder?
Yeah, well, I mean, with RDO, I don't know much more than that.
So you want to be able to back up the ephemeral storage that's being provided on those VMs.
Yeah, we want to periodically, write scripts that either through the API or whatever, periodically back things up into a different spindle to make sure that,
So that is a controversial topic that I'm not involved with, but I can tell you how the discussion lists normally go for that. And it's typically, when we're talking about ephemeral storage, people will tell you that it needs to be stateless in the sense that you can lose those VMs at any point in time. I would recommend that if you want to look into anything persistent, that you would look at considering remote storage like with Cinder. There have been a variety of blueprints that have been provided to kind of make ephemeral storage something that is persistent, but that goes against what people view as for ephemeral storage, and that's, again, that you should be able to lose those. And you should be able to recreate from like a Git repository or something, and orchestrate that VM back to the state to actually run.
What all things have run databases?
So he was asking the case of for running with databases. So again, like a lot of the databases that cases that I've dealt with, they're actually running that over some sort of remote storage. So I deal with those cases today for whatever vendor I'm helping, but unfortunately, I don't have anything for you in terms of like backups on the thermal storage.
So like say.
Oh, actually, we need to get to the next presenter, so let's take the
I
rest
can
of our
talk to
question
you,
offline, and yeah, Mike will still be here, and other questions that you guys have, let's do that offline, and in the meantime, let's reset the room. Please give Mike a huge warm round of applause. Thank you so much, Mike. And like I said, he's a regular. We're still lucky to have him in this area, and he's here at the meetups a lot. So this isn't your last conversation on Cinder, put it that way. So thanks a lot, Mike Perez. We will reset, and just for kicks and giggles, let's practice it again. I don't know how. Fingers crossed this will actually work, and then you folks over there don't have to squint so much. We actually had a Halloween party in here earlier today, so if there's glitter on your chair, as I noticed there is now on the back of my pants, there's a reason for that. Little costume party. And so the room looked really, really different a couple hours ago, and things got a little crazy. So we'll see if we can get stuff working again. Clearly that needs a second to come online. And I believe all of you. Oh, and Mike has some Cinder stickers for you. Perfect. Be sure to grab some of those before you leave as well. So we have so much fun stuff for you this time. So hope you all appreciate it. And as we reset here for the next presentation, I will remind you to fill out those forms. Make sure that if you didn't get a form, the lovely Alina will make sure that you get one. And for your efforts, we will be, once you turn in the form, we'll give you a raffle ticket. Amanda, I think, has the raffle tickets up here in her Halloween trick or treat. Okay, so this is quite a treat. We'll be raffling this off at the end of the night, and notice a few of you had to leave early, so your odds are getting better by the minute. There's also, I noticed, a lot of cupcakes left, so don't be shy about that sugar rush that's going to get you through the next presentation. You're not that, no, not at all. So I want to make sure your slides work. Okay. Get that rolling. Okay, I love your sweatshirt, by the way. Did you get that at OSCON? Yeah, did you get that at OSCON? I know what it is, because I have one like it that I got at OSCON. Although mine is Rabbit MQ, the other with the little bunny, and yeah. I wear that in here sometimes, but we realized last time when we started talking about dev platforms and application developers that this wasn't quite the audience. You guys were sticking to your OpenStack guns. A lot of the conversations we're having, we're noticing where the infrastructure as a service is conversation is starting to bleed into the platform as a service conversations, and we do a lot of crowd chats on OpenStack, and that's always the first, second, or third question we seem to be getting these days. So it's becoming more common, Oh, pens. Good idea, Rick. You guys are full of good ideas. Eventually, I would predict that within a year or so, we will be talking more about platforms as a service. Pens over here on the right. All right, let's get the pens passed out so we're not running around in the middle of, I like that shirt too. Did we give you that one at the birthday party? In the back, the OpenStack shirt? Alina, yeah, I think Alina may have handed that to you herself. Yeah. So for those of you guys who don't, I mean, if you haven't met Alina yet, she's just so fabulous. And the third member of our team, fourth really, Sean's not here, Rick, Evans, me, is Maria. Alina Mihalis, thank you so much for everything you do. She feeds you, she keeps the lights on, she keeps the projections up most of the time, and gets you a lot of nice beer. Actually, I'm usually the one they send out for the beer run. Go figure. But this time they didn't question if my credit card. You guys remember that last beer run? Thought I was gonna get arrested. People were convinced I stole that card. I was like, are you kidding? If I stole a credit card, I'm not gonna go to Safeway and buy 3 cases of Corona. All right, I'm gonna buy champagne, duh. But you ready? All right, fantastic. Okay, so we're gonna kind of reset the Trav. Are we good here? All right, cool. All right, so now we're gonna talk about graffiti. And Michael Aday is the perfect person to talk to you about graffiti. He works in the team here at HP Helion, and also works really closely with the Intel folks who collaborate on this project as well. So, and again, for those of you who weren't here in the beginning, I'm Lisa Marine Amphy. I'm at HP Cloud Angel. Rick Evans, my co-host of the meeting. Ravens HP. Revens HP. And Mike Aday at Mayday. Just at Mayday. Thanks a lot, Mike. Take it away. Are you mic'd up?
Yep.
No, we had.
Am I mic?
Are you mic'd up? I don't think we have enough mics here tonight, so here's other mics.
It's open mic night. I'll just go ahead and clean them all out.
Okay, take it away, Mike.
So apparently I'm mic 2 this
But your
evening.
mic is not on.
Am I on now?
That's a lot better.
All right, sorry about that. So just to recap the jokes, it's open mic night. Thank you, I appreciate that. So, so thanks for the intro, Lisa. I have a great job at HP. I manage our technical collaboration with Intel around OpenStack. You might be aware that HP is contributing a ton of code in OpenStack, and so is Intel. And this project happens to be one that we collaborated on upstream. So both companies checked in about 30,000 lines of code, and roughly, and it became the seed of a project called Graffiti. And what we're really trying to do with Graffiti is address the situation where, okay, so first off, there's a disclaimer, right? Even though all of this is upstream, we still have an HP disclaimer. Apologies for that. But the project started as a very organic project. Intel had an engineer, his name was Murali Sundar. He was working on a particular problem set. Travis Tripp on our side was working on the same problem. And so we became aware that we were kind of working on the same problem through our collaboration, and we decided to partner up. And we decided to do it all upstream. So all this code is upstream. All this code is in trunk right now. And just to kind of round it out a little bit, I'm kind of jumping ahead of myself. All of this code has now been picked up by Glance and is a metadata service, a generalized metadata service for Glance. We're also talking with another project inside of OpenStack called Congress. How many of you guys have heard of Graffiti in Congress? How many of you guys have heard of Graffiti? Okay. How many of you guys have heard of Congress?
It's a VMware project.
Congress is, it was started by a guy who happens to work at VMware, but it is in fact a community project, just as Graffiti is. And so, you know, forget company affiliations for a few minutes, right? And let's just talk about the community, because all of these things are really done for the community. So Congress is fully upstream, and Graffiti is also fully upstream. So the problem set that we were working on was, you all know that, and Mike just illustrated, some degree of abstraction within Cinder, right? It's great if you can have a single mount, dismount instruction set that applies to 30, 40, 50, however many, I hope all of them vendors, and not have to learn esoteric, an esoteric command structure for mount, dismount, for CRUD operations on volumes, right? And so that level of abstraction is really great. But the problem with abstraction is that you begin to lose intelligence about what you've learned works and what you've learned doesn't work. And so the way that I think about this problem is, in 1993, 1994, Microsoft Windows came out, Windows NT came out, and it had a RAID volume manager in it. And so you could do software RAID. And everybody thought, wow, this is fantastic. I can do software RAID. So I'll stick 5 volumes in, and I'll have a RAID 5 set. Everything will be golden. And if one of those drives goes down, then everything's still okay. I can replace the volume and I can go on. The problem with that was not that it was a software RAID. The problem with that was that you were using machine resources that were intended for other things. And it was rapidly replaced with hardware RAID. And so it became very uneconomic, ineconomic for me to run a software RAID inside of that machine. And by 1996, 1997, RAID controllers were available that were so cheap and they were so high performance that it didn't make any sense anymore to run software RAID. It was a huge tax on the overall system. It had its own problems in terms of durability. If the machine happened to go down, if your operating system dropped, then you lost your mind with your RAID set, right? You couldn't write out your cache. You had dirty pages in your RAID set. All of a sudden, now you had volume corruption, and it was a horrible thing, right? And that still happened with some of the early RAID cards, but most of them had battery backup, and they would, whenever the machine would come back up, you would be able to write out your cache, and everything would be hunky-dory. So there's 2 important lessons here. The first lesson is that abstraction is fantastic for some operations. And the second lesson is that whenever you're in a high-performance scenario, abstraction doesn't always work, right? So to that end, there's a lot of enterprise hardware out there today. HP sells a ton of enterprise hardware in terms of storage and network. And it makes a lot of sense to be able to use that hardware inside of an OpenStack implementation without having it abstracted down to a lowest common denominator functionality. And it also makes a lot of sense to be able to tag workloads inside of OpenStack and be able to selectively schedule the specialized hardware that you need to run that workload. So that's what Graffiti is about. All that Graffiti does is it provides this universal metadata library and tagging system for resources within OpenStack and for workloads within OpenStack. So you can identify requirements for a workload, and you can identify capabilities of specialized hardware. And those services then get picked up by other capabilities. For example, Congress is a policy engine, and it allows you to selectively choose what you're going to do based on the presence of metadata. So now I can apply Graffiti with Congress, and I can have some action that's taken automatically by the system or manned by the system that's based on the data that the system is presenting. So this becomes super cool whenever you start thinking about self-healing scenarios or reactive scenarios in the case that you have a failure on a volume, moving workloads to another region or another volume or another set of resources, or repairing the necessary specialized hardware under a workload. So, so what we were trying to do was, we're not doing a lot of special stuff inside of Graffiti. What we're trying to do is just make a lot of this data more accessible. because within OpenStack, a lot of this data is buried in the deepest, darkest bowels of the system, right? I've already gone through the goals of Graffiti. I apologize for stepping over my slides. But we're really trying to make it possible to identify requirements from a workload perspective and to identify capabilities from a hardware perspective. So the scenarios for Graffiti, this is kind of when we first started out. It was really just to launch a VM based on a specific set of capabilities. So you can think about a glance image that was tagged with a specific set of capabilities in the hardware. For example, how many of you guys do media processing in the cloud? Nobody does media really? Media transcoding? Nobody does it? Okay. I work with a pretty large company that does a lot of it. And their scenario for public cloud use is they run out and they grab a whole bunch of 8XL machines, right, VMs, in a region of a public cloud, let's say east, right? So they grab 30 8XLs, and then they interrogate the 8XLs. What generation processor are you? And the reason that they do that is because Intel processors, over the years, they've picked up new instructions. And inside of some of the latest generation of Intel processors, you have AVX instruction set. And if you run the workload on an AVX instruction set, then it runs in about half the time that it would, say, on a Gen 6 Xeon, right? And so what they're doing is they're looking for a more efficient way to use specialized hardware in that 8XL, right? Amazon, like if you go out and you look at the characteristics on an 8XL, they're going to tell you a core is a core, right? I'm going to give you a 16-core machine. But they don't tell you what generation the cores are. They don't tell you how you can use selective increases in the generations in the cores and improve your execution time, right? So this is really an economy scale, right? An economy play. Because we don't have Graffiti today, right? What this company will do is they'll run out and grab 30 of them. They'll interrogate them. They may find 5 that they really want to use. So those 30 are occupied until they realize, hey, these other 25 over here are not ones that I want to use, right? Then they disconnect those, delete those instances, use the 5 that they want. What Graffiti does is it allows them to say, hey, I want a 16-core machine with AVX instruction set. So it simplifies the provisioning greatly.
Is that similar to cluster management like Mesos or Yaml?
So the question is it similar to Mesos or?
Yaml. Yaml is sort of Hadoop 2.0 is a repeat cluster management system.
So this is in fact not similar to a cluster management, right? Mesos, you can determine characteristics in Mesos, but you can't necessarily schedule based on those because the underlying hardware isn't representing what its capabilities are.
Of course, it's not perfect. But,
yeah.
Just wanted to try to do both scheduling and resource allocation.
So the question is, does Graffiti do scheduling and resource allocation? And the answer is scheduling does neither, Graffiti does neither scheduling or resource allocation. What Graffiti does is resource tagging. And what Congress does is it provides input into a schedule feature, a schedule filter, to determine which is appropriate based on the tagging, and it allocates resources based on that out of Nova Schedule.
Congress is a policy.
Congress is a policy engine, that is correct.
So this is only the theory.
It is an alternative service. So Graffiti, whenever you graffiti something, you tag it. That's where the name came from. So in this first instance, what we wanted to do was tag a glance image with certain capability requirements. And then we wanted to spin that up be guided essentially to the right flavor to be able to run that glance image. So there's a lot of different ways to do that. you can go and you can look at the code inside of Nova Scheduler, inside of the databases that run Nova Scheduler, inside of your resource databases. You can go and interrogate the code, and you can try to figure out which is the right asset to deploy on, right? But there's not a lot of people. I mean, obviously there are a few, right? But there's not a lot of people who really, really enjoy reading this data. Because sometimes the data looks like this, right? Where, I mean, there's a lot of values in there that you can intuit what they are, but there's not a lot of really extensive tags in there, are there? It's not XML. And then there are other interesting things like trying to figure out what the values mean. You may think that you have RAM data, RAM size on a VM, but you may not have it. It may just have really small storage, or it may have really large RAM. You know, so figuring out which is the right field, which is the right piece of data, how am I actually going to use it, becomes kind of challenging. And so what we were trying to do with Graffiti was bubble all of that stuff up into a key value store that was very human readable, very usable. There are Horizon extensions to allow the data to be piped into the UI. It's obviously command line accessible as well, so it just makes it a lot more consumable across the system. So the whole intention was there had to be a better way. And that's what we did. We developed this key value store to cleanly declare and discover what types of metadata were being applied to resources and workloads in the system. And this applies, you know, the initial application was to Glance, but this applies to a lot of different other projects as well. There are flavors for a lot of different resources. Flavors for underlying VM host, flavors for underlying networks. There's a lot of different ways to use this data. So Glance is kind of the first that we've been accepted into, but we're definitely trying to ensure that this gets applied more uniformly across the system. And so this is very democratic. Any user, any vendor, any ISV, any admin in the system can define metadata. There's a single data dictionary that's used of OpenStack. And so you can declare it, you can tag it on a resource, you can access it, change it, all through this UI for management of the data dictionary. And it can be used for a lot of different things like Fuel, O, so on and so forth. So we're very democratic about how the data can be used. And once it's in the system, then it becomes an aspect, a management aspect of the resources and the workloads that are in the system. So since nobody does media, does anybody do cryptography in the cloud? No? So how many of you guys have heard of Xeon Phi? Xeon Phi is a very, very, very multi-core coprocessor that's used for a variety of functions. But in this case, I'm talking about AES-NI. And so AES-NI, crypto operation, stream operation, can be very taxing on existing multi-core machines. So if you're trying to do, say, file encryption, decryption operations with AES-NI, then you can have very, very long compute times if you're using general purpose processor. As an accelerator. It's a card that gets added into the system. It's treated as a coprocessor. And it's going to have anywhere from 24 to a lot more cores. And all these cores are specialized for compute operations. They're specialized for transcoding. You can use it for modeling operations. Any kind of a really, really intensive mathematical operation you're going to be able to do on these cores. And you're going to be able to do it extremely quickly. a lot more quickly than a general purpose processor. So whenever you start thinking about how you could possibly apply Graffiti, if you wanted to use this type of functionality inside of OpenStack today, it just doesn't exist. With Xeon Phi, you could actually target a resource to a VM that was hosted on a machine that had a Xeon Phi. And then your workload's going to take advantage of that coprocessor.
But it's still not bare metal performance.
So the question is it bare metal type performance? And the answer is it's very bare metal type performance. Depending on how you provision the host, if you're running inside of a VM, you're still going to have some overhead that's associated with management of the VM. The resource is going to be available so that you can actually use it inside of that VM. So I think the best way to think about it would be, I provisioned a VM on a very large host. The host had 16 processors. I maybe got 12, right? But the compute operations that I really want to accelerate are actually being offloaded onto this device.
So it's HPC.
Very much, it's very targeted at HPC. It's very targeted at critical storage, high resiliency storage, fault tolerant storage, even high-speed networking, right? A definition of a new flavor that's InfiniBand, for example, and being able to use InfiniBand to have a much higher throughput overall in the system. So this is what it looks like whenever you're actually using Graffiti. You're going to have capabilities that you're defining within the hardware, and the capabilities are going to be in this key value store, right? So you're going to be able to have groups of categories that you define, and in the default implementation of the project, we define a data dictionary for you, but you can go in and edit any of these values, and none of these values will materially mess up OpenStack. Defining the values, it's metadata, right? So if the underlying capabilities of the system, if you don't have, for example, a policy engine configured to use it, defining the metadata isn't going to do anything, right? Except make the system more accessible to an admin. Because then they're going to be able to look at the services, the capabilities of the different underlying hardware in OpenStack, as opposed to just having to go through and grovel code to figure out what the capabilities are.
So it's a sort of matching. What about a match? Sort of matchmaking.
It is. So he asked the question. It's sort of like a matchmaking algorithm or matchmaking system. And the answer is yes. It's kind of like half of a matchmaking system, right? Because if you're gonna try to matchmake, right, you have to first ask questions. What do you like, right? Do you like long walks on the beach? Do you like Barry Manilow? Do you like champagne? Do you like pina coladas? So if somebody hates pina coladas and another person loves pina coladas, it's probably not a match, right? So in this case, it would be your workload loves Intel architecture. You only have ARM. It's probably not a match, right? You get the idea. So, so whenever we're using that metadata, then you're just specifying. You're having the user specify what they're looking for. This is kind of the other side of the match, right? And with Congress, and this is a great analogy actually, with Congress, what we get is automated matchmaking. So now we've already expressed what the capabilities are from each side, and then it just becomes a simple factor of automating the matchmaking process, and that's done with a policy engine and a schedule filter. So the overall vision of Graffiti, and we're well on our way here, is that you'll be able to have capability tagging, you'll be able to search through the infrastructure within the cloud, determine what the adequate infrastructure is, collect it, and then assign resources to it. assigned workloads to it. So Glance, Nova, Neutron, all metadata. So I know that you guys are bored listening to me. There's a couple of videos. And obviously, if you haven't tried our Helium product, please do. We just had our general availability of the commercial targeted release of the product, and we just had 1.4 of our community release, and we're rapidly accelerating our release schedule around these products. So check it out. Let us know what you think. As I said, this project is in. It's not released in Juno, but it's pretty far along. So go check it out. Any questions? Yeah. I promise you that I did not plant any questions in the audience. Okay. And by the way, I do like pina coladas. Okay.
Your son started singing that song. You know that song? Because my dad made me listen to it all the time.
And now everybody on the internet knows how horrible a father I am. Thank you. Yes, I made my child sleep through, or watch my presentation.
This is his second meetup that he's been to. I'm starting to think he's kind of a groupie.
He's getting into osmosis.
Yeah.
I figure start young,
Well, question them, Carlos and Rick, and also Alina. I want to make sure as you turn in your surveys to Alina and get your raffle tickets that we also give you. We're going to send everybody home with something. So not everyone is late, but we do have something for everyone. So if you've already given your ticket, you can just sort of flag Alina down and I'll give her the goodies that are in this box. And I can't even remember what they are, but I was told they're very, very good. Something that Intel helped us out with as well. So perfect timing here. So customers first. Sorry, Rick. I'm going to go over here to Carlos and then I'll come back to you.
So I'm kind of new to this stuff, but
everybody was new once.
Doesn't this seem like an extension of flavors? Or somehow very related? Like Flavors has a lot of this functionality.
It is an extension of Flavors. It is very similar to Flavors, but it's also cross-project. Cross-project.
Always.
So think of it as a common way to identify flavors.
Okay, and I've been informed that I've already messed up the process. So apparently the winner gets the slate and all the runner-ups are gonna get that, which is crazy because that means only one person is this. So I just to make it easy, and also someone has to leave early. Okay, Rick, here.
Okay, so let's get back to the idea that I want to tag specific CPUs somewhere in the data.
Okay.
And I got this list. I totally get the database. What I don't get is how am I going to find that blade, this blade from the right in that rack? How do I know it's still there? How do I know? Is it a MAC addresses on the back end? IP addresses? How do I know when I allocate that? What do you call that? AVX, whatever chip. AVX chip, and then I get that right chip.
So whenever you register resources in OpenStack, they all have a unique identifier. So if you don't have a unique identifier, then you can't possibly tie resources to it, right?
Is that a keystone?
It's not a keystone identity. Keystone is user identity. So think about how you register a new Nova host, right? In the process that you go through that, and then I'll start to make more sense. These are not just soft values that are identified; they're identified on resources.
That's the thing. I normally think of OpenStack. OpenStack is allocating soft values or ephemeral values. You're talking about hard resources.
Yeah.
And I didn't know that.
So
resources were also tagged with some sort of permanent identifier.
There's a unique identifier for all us.
Where is that stored? That's a good question about Keystone. Where is that stored? Is that in Nova?
Well, we can talk about it.
Okay.
I love it. I think you've been to more meetups than anybody else in this room because before we started hosting this one, you're always there. And I love how we learn something new every single time. It's so fantastic. Okay, any more questions? Mike's thinking of all the really hard questions. He's got an IPA in his hand, so.
Stump the chump.
Yeah,
Stump the
so
chump.
he's gonna get you. He's still thinking.
Be gentle, guys. Come on. It's community.
So using the manual tagging or metadata, it looks like a manual scheduling or resource allocation.
So
it's all semi-manual.
So initially this is very manual, right?
Or brute force,
but-
very
Initially this is very manual. But you can think of this as being an extension to other services, right? So whenever you register a new node, whenever you register a new piece of hardware inside of a system, you can very easily collect this type of data off of it. But there was no single place that you could really call, no service that you could really call to tag that data in a very usable way. And so that's what this is providing. Yeah, to your point, you could do this in an automated way. And we do see that as critical.
Otherwise, user have to be at an expert level, or at least know something about what they are doing.
So you kind of have a cold start problem, right? You have a cold start problem because in today's cloud, there's no capability to collect this information in a very ubiquitous way. So you need to have a manual tagging process, right? Unless you're going to rebuild the entire infrastructure, which I guess you could over time.
So what do you think about your take on next step, the roadmap ahead? I mean, if this is very successful, you can do something more.
Well,
more automatic.
So automated scheduling, automated tagging whenever you register devices. Whenever you bring up a new storage infrastructure and you allocate it into OpenStack, obviously tagging that storage infrastructure with capabilities, examining and interrogating the capabilities out of the system, being able to profile workloads in an automated way and tag them, and then scheduling filters that go out and look for these types of activities in conjunction with a policy engine, right? I mean, all of those things are definitely within the realm of possibility.
So it's a sort of, it's a far way to go. It's a far way to go.
It's a what?
I mean, it's a long way to go.
Well, yeah, I mean,
It's just started, to be honest.
We started this project, so our first check-in in this project was about 6 months ago.
Thank you.
So this is a 6-month-old project, and we've already been picked up by plants. So
that's actually very useful.
It's pretty young, but it's moving pretty quickly.
OpenStack just 5 years old, so in
yeah,
that
4 years old.
Yeah, you guys have done an awesome job. That's, I just got started, and it's come.
We're in a target-rich environment, right, for improving the platform.
Yeah.
There's a lot of opportunities.
Yeah, I was put together a number of this, he's been like, just lights out on this. So soft. Okay.
It's actually useful in what to do.
It's actually a question to what is can I have storage capabilities on these phone boxes and simplify driver creation in terms of capabilities, image capabilities of target system and initiators?
Simplify driver creation. So, just for Cinder. Just for Cinder?
So, yeah, the capabilities that the vendors provide, every single vendor driver is providing to the scheduler the capabilities that it's able to perform. So this kind of goes back to those volume types where there is a request coming in with a particular volume type associated with it, and there's a requirement for volume that the user wants in terms of create this volume, but I want to have a certain amount of like guaranteed IOPS or whatever that the different vendors are able to provide. And from there, the request will go through, the scheduler will look at which backends can actually meet that request. And so again, those capabilities are being sent up from the driver on behalf of the backend storage, and it could be a giant storage pool, whatever. And from there, the scheduler can go ahead and make the decision based on the request coming in, which backend can actually take that request.
But if I have just a generic storage, I can put together tags around generic storage to feed into Cinder.
Yeah, so the question was having your own generic driver and putting in your own capabilities to provide up to the scheduler, that same idea. And absolutely, I mean, you can take any vendor, I mean, there's already a generic block device driver that you can do that with today if you really wanted to. And then you can easily add in there's just a method in there that's called volume stats, and it's just providing a data structure up to the scheduler of those capabilities. And then from there, you are able to associate key value from volume types. These are the capabilities that a particular volume type or tier that you want to be available for certain volume creation requests. And then from there, those will be mapped to whichever backend devices or backend storage that can actually meet those capability requirements.
Okay, other questions? One more before we go. Yeah. That's it? Okay, so did everybody turn in your review, whatever it was? No one's left? Okay, so first of all, I want to once again thank our amazing performers, should I call them? Our presenters, Mike Day, Mike Perez. Give them another round of applause. Thank you guys. Thank you. Absolutely huge shout out to Alina. Just thank you so much. Yes. Thank you to all of you guys on the Google. I got your tweets. We were listening, we were paying attention. So thank you for participating as well. And thank you to Rick for co-hosting this beast with me week in and week out. We will get back to the format where we'll do the trainings. We'll start when Sean gets back in town, and we'll have Paulina back here, and we'll start again with the training manuals. I think that'll be in November after the OpenStack Summit, so I don't believe we'll meet in 2 weeks, so just check the schedule. So we'll see when the next one is. And Saba, thank you so much for sorting out the whole Google Hangout. You bailed us out because that's probably my #1 complaint that I get if we don't do it. So I hope you all enjoyed it. You guys can all thank Saba, and he'll probably post it. You're going to post it on YouTube?
I will post it, of course.
Okay, and then you put the link on the, okay.
Yeah.
Did we get you on camera? Come on, you've been doing this to me all night. There he is.
Hello.
All right. Handsome man. Thank you. Okay, so I just kind of assumed that by now someone would show up with something for me to, hey, you want to help us out? Little Mike? Can you help us out? You want to help us with the raffle? You want to draw the winner? That way they know that it wasn't fixed.
Oh.
Well, if your heart isn't in the... I don't think he needs a slate. He's playing games online on something that's much more advanced than a slate. So I don't have the Halloween thing yet, but we're gonna get it. So Alina, what are we ready to draw? Oh, sorry, 2 minutes. False alarm. We'll sit here and.
Speaking of advanced, how many of you guys have seen Sprout?
How many of you guys have seen Sprout?
Is that not the coolest thing ever?
Yeah.
So Sprout's a new generation desktop that we just introduced, literally. So Sprout was codenamed Merlin, and it's a new generation desktop. We just released it earlier, I guess it was earlier this week actually. And it looks kind of funky. It's got this weird, device that's hanging over the top of your monitor. So pretty large monitor, little device that comes over the top, and it's got a pad that slides in and magnetically attaches to the base of the machine, which is behind the monitor. And it allows you to merge virtual objects and physical objects. So you can actually lay something physical on the pad, and it will appear, it's scanned automatically. There's a 2D camera and a 3D camera in in the overhang that comes over the top of the marble. And it will actually merge them together. It's nuts. You gotta see it. So the base is actually a 20-point capacitive touch pad. So it can actually detect your manipulation of the physical objects on the ground. And the other big announcement that we had last week, or I'm sorry, earlier this week, was multi-jet fusion. It's HP's commercial entry into 3D printing. It's 10 times faster than any existing 3D printer, and it prints at a much higher, like order of magnitude higher resolution than any commercial 3D printer available. So how many of you guys have MakerBots? How many of you guys want MakerBots? All right, so I want a MakerBot. So I was pretty excited about this because it's pretty amazing. There are cartridges, so you know with a MakerBot you have to get a roll of PLA or whatever to use as your 3D substrate, and it's fused deposition. Our stuff is still fused deposition, but it's a cartridge-based system. So you can load up 4 different types, and it will automatically print with different types. It's pretty nuts. So
okay. Yeah, we said 2 minutes.
Oh, sorry.
That's okay. I'm just teasing you. Do you guys know Justin Ulal has been to almost every meetup as well too. So just say hi to everybody. If you guys haven't met Justin, he's like just the nicest person in the world, and an awesome stacker. So I just wanted to give you a little shout out. So introduce yourself to Justin. You guys are the community, so you should know each other. So speaking of community, the youngest member of our community is going to now decide who wins this slate. Pick one.
Remember, 35.
Pick one. Oh, the HP employees are not allowed to win. And oh, you were so close. What number?
34.
34. Hang on to it though, because you can't win for HP. You don't work for HP, right? Not an HP employee? I think not, because you're wearing a name tag. All righty. Come on up. 34, lucky
If you
number.
would have drawn 35, I would have totally.
I know we would have. I would have thought it was that. What's your name?
Kali.
Kali? Yeah, where are you from?
VMware.
You're from VMware. Awesome. You work in the Palo Alto office? Okay, what do you do?
I'm a developer.
Why are you backing up? I'm not.
He's scared of you. He's like, give me the slate.
Yeah, so you gotta work for this. We want to know the members of the community. So you're a developer, and do you develop on OpenStack projects?
No, I develop on Python, so
Nice. Okay, we like that. And do you work with Sean Roberts?
I know.
Did he tell you to come here? Sean's usually here. But I was going to say, we're changing the format, so don't tell on us. Don't tell Sean. Even though it's on Google Hangout and you can watch the whole thing. Okay, so you have now won a slate. Thank you very much, and we hope that we see you at a lot more meetups in the future. Thank you.
You also get a cupcake.
Oh, you also get a cupcake. All right. So yeah, thank you for the, take some cupcakes. The food was unbelievable. Thank you, Alina. The balloon's such a nice touch. My secret admirer who brought me a gluten-free beer. Love you. Wow, that was nice. Thank you, Alina, for the gluten-free pizza as well. And enjoy, drive safely home, and don't forget to take a cupcake.